Now, dear students, we will learn about the scope of variable. Scope is a region of the program, and there are three places where a variable can be declared. Like you can see over here, I can declare a variable over here, or I can declare a variable over here, or I can declare a variable above the void setup. So these are the three places at which we can declare a variable. There are two types of variables, like the local variable, and the other type is the global variable. Variable that are declared are inside a function or a block are called local variables. Let's say if I write over here int x, and actually we have also studied in the data type video that how we declare a variable. First of all, we write the data type, that is int, then we write the variable name, and if you want to declare multiple variables with the same data type, then what you will do, that over here write x comma, then let's say the second variable is y, then a semicolon. And let's say if I want to declare a single variable like int, and with the name z, and then a semicolon. These variables are only accessible in the while loop. X, y, and z, you cannot access these variables in the void setup, cannot access over here outside of the function. These are only available inside the void loop. So these both are the int x, y, the int z, x, y, z, these all three variables are only accessed in the loop, while loop, so they are called as local variables. So in the comment I can write these are local variables, and this is also a local variable. And if I write some variable above the void setup over here, so if I say that, let's say int, and give it a name t, or let's say s, and give some this is just the syntax. The first data type you have to write, specify the data type, then the variable name, then the semicolon. Or let's say I declare a variable with the data type float and say c, and initialize it with 0. Then these variables like t, s, and c, these are outside of both the functions, the void setup function and the void loop function. So these both are the global variable. Like over here, this is also global variable, as these three variables can be used in the void setup function, can be used in the void loop function, but these three variables x, y, z cannot be used in the void setup, cannot be used over here at the place of outside of the functions, because these three are only specific to this void loop function and can only be accessed within this function. That is why these are called local variables. Over here you can also initialize a value of x, like x is equal to 10, then provide a semicolon, or you can say y is equal to 100, and you can also say z is equal to 89. So this is actually the declaration of the variable, and these three is actually the initialization of the variable. Over here I can write over here initialization of variable x with value of 10. Similarly, this is the initialization of variable y with value 100, and over here this is the initialization of variable z with value 89. So in this way you can initialize the variable, declare the variable. So let's say if I let's save this code and let's run the simulation and see what happens. Actually nothing has happened because we haven't written any piece of code that should print something on the serial monitor or do something else. But no error has been generated by the workflow. So let's just stop the simulation and let's say if I access these variables t, s and c in the loop. Let's say I write that t is equal to 25 and then say s is equal to 78 and let's say c is equal to 12.5. It's in decimal. We can initialize it in decimal because we had declared with the float variable, float data type. So let's save this and let's run the simulation and let's see if the compiler generates any error. No error has been generated, which means that this global variable can be used over here in the loop function. This can also be used in the void setup. Now let's try if we initialize these x and y, z outside of the function. Like say if I say x is equal to 69 and let's say y is equal to 58, and now let's save and let's stop the simulation. Let's run this again simulation and see what will happen. Over here you can see that build failed. This is because that it says that the error x does not name a type x is equal to 69, which means that let me close this. These variables are actually initialized over here. These are only local to this loop function and cannot be accessed over here in any other function. Let's say if I remove from this function initialization from this function, let's copy and paste it over here in the void setup. Let's say now what I have done, that the local variables x, y, z that are local to loop, I have tried to initialize it in the void setup. So let's save this and let's run the simulation again and see what happens. You can see that it again generated an error because these x, y are local variables to loop function. These are not global variables. Let's see if I initialize the value the variable t with 78 and the variable s with 47, and let's save this. Now let's see if it generates an error or it works fine, as I have initialized the global variable in the void setup. So let's run the simulation and let's see what happens. You now can see that no error has been generated by the workflow, which means that these global variables can be accessed in the setup function, can be accessed in the loop function, but these local variables that are local to loop function cannot be accessed outside of this loop. So hope you have understood the concept of local and global variables in the C programming language, specifically for programming the Arduino microcontroller.